today we're going to talk about the ability to take intelligence that you would normally associate with a person, some sort of cognitive task or something reasonably complicated that you couldn't ordinarily program, and codify that into an IoT device. So we're going to be talking about IoT, and we're going to be talking about edge. And I just wanted to clarify what I meant by IoT. And really, generally, we're thinking about something that is going to interface between the digital world and the analog world, you know, the real world. And when I talk about edge compute, I'm not talking about our edge Route 53 CloudFront sort of edge capability that you would normally associate with content delivery. What I mean by edge is an independent, decentralized ability to run compute in remote locations, potentially, and not necessarily with a dependency on a connection to the cloud. So that's what I mean by edge. So what we're briefly going to talk about is the DeepLens device as a good example of an edge device. We're going to talk about how SageMaker and Greengrass interact. SageMaker being our fully managed deep learning notebook training and deployment environment, and Greengrass being a flavor of our opinionated way to run edge compute. I'm going to show you how I built and trained a model using SageMaker and deployed that using Greengrass. And of course, we've got a demo. So what happens if you go and get IoT and deep learning and you get, and you put it in a blender with a bit of edge? What does that look like? So we kind of thought that this DeepLens would be our idea of a combination of those three things. And it comes with a whole bunch of tech on it. It's got an attached webcam. It's got 8 gigs of RAM. It's got an Intel Atom processor. And really, it's got the whole idea of the DeepLens is as a developer tool to get started really quickly with deep learning. And we think that you should be able to unbox one and actually get going with an experiment inside 10 minutes. So that's a pretty good challenge. And it's got packaged with it a whole bunch of sample projects, so things that will do object recognition or take a photo of a location trained by Picasso's painting of that, and the DeepLens will give you its artistic interpretation of the scene that it's giving you. All sorts of stuff. Can we cut to the demo, please? So this is the object detection algorithm that's running on the DeepLens, and so it should be picking me up as a person. And if I turn it on the audience, it might pick up some more people. It may also pick up people as water bottles or all sorts of stuff. So we can see, probably not close. There we go. We've got a whole bunch of people coming through. So I'm running this wirelessly, and you'll see why later, which is always a bit of a risk. But this is really just here as a demo to show you what the system is seeing. Because in fact, what's really more important is that it's publishing this stuff over MQTT. So we're turning a very, very high bandwidth thing, i.e. video, into a really low bandwidth thing, i.e. MQTT. So you can see it's publishing over MQTT what it can see, which needs a lot less bandwidth than a raw video feed. Okay, can we cut back to the slides, please? I'm just going to pre-start my next demo so it's all ready for you. Cool. So we've got all of these, these models that come with the DeepLens, and yeah, that's kind of cool. And I guess maybe you could program something to recognize your cat or your dog, or use the object detection to tell if birds are one of the things in the object detection. So you could point it at your canary cage, and it would tell you if your bird's in its cage or not. So there is stuff that you can do with this, but why are we here? Like, why did we build this DeepLens? Like, what problem are we actually trying to solve with this technology, or is it just technology for technology's sake? Well, when I think about these kind of problems, I think about problems that are remote, problems that you used to rely on people to tell, and problems that applying at scale can solve really big bottlenecks. And a good example of that is classifying a fruit. So this idea of writing a program to tell if an apple is green or red, that seems pretty easy because, red, green, blue with 3 color channels, you can do the maths, right? But what happens if you're trying to tell the difference between something that's ripe or something that's not ripe, or a bit of orange that has disease on it? These things are much more subtle to program. And this is where deep learning allows you to train by example, and you don't necessarily have to write a program that understands this. You can supply data for it to generalize and be able to work this out itself. And also think about all other sorts of ways that you can be compliant with this. So the ability to bring your data to the edge, process it on the edge, and not necessarily send it anywhere may be relevant for some medical use cases, but it's also really relevant for a whole bunch of industrial use cases. And think of an oil rig, usually which would only have a satellite internet connection, where it wouldn't necessarily make sense to stream 75 parallel video streams over a satellite feed. And I'm not sure if any of you saw Jenny's previous session, but the concept of being able to tell if someone's wearing their hard hat or not is a really interesting problem, but not if you can't afford to send the data through to the cloud. So this is where edge becomes really interesting. And this begs the question, like, what does the data center of the future look like? Is it racks and racks of servers everywhere, or is it this fog of distributed devices, all of which may have a limited amount of compute on board and are able to sort of pair together and solve a problem collectively? And so when I was thinking about this, I thought about one of the problems that one of my mining customers had, and that's around understanding where your heavy equipment is underground. And there's lots of fancy ways of solving this problem, like using RFID tags and using micro GPS and all kinds of stuff. But I started to think about, people work out where they are just by using their visual cues. And on the top left of this picture is a really good example of a lot of mines underground have a really good codified way of determining where you are via these signs. So hang on to this image, and you can see I've got a couple of signs floating around. So this is what my demo is going to be about, using vision to sort of understand where you are. So let's take a step back and just recap on what is inside Greengrass and why it's useful. Greengrass can run just as easily on a Raspberry Pi or an x86 piece of compute or an ARM piece of compute that runs Linux. So don't get caught up with the DeepLens. The DeepLens is just a tool to demonstrate the job. And Greengrass can run on just about any device of your liking. But Greengrass gives you this ability to write code like you would write it for Lambda and deploy it out onto the edge and make reactions to data without a connection to the cloud. It has an ability for local messaging. So Greengrass can act as a hub to connect further on down the chain to other devices, in an entirely offline mode. You can cache data, and of course, security is always a priority. So everything's TLS encrypted using certificate-based authentication, just like our normal IoT services. And the general idea is that you bake this stuff into your equipment at manufacturer. You don't actually even have to say that you're running Greengrass on the inside. The Greengrass runtime on this DeepLens actually installs just as a Debian package. It's running Ubuntu operating system sitting on there, so it's just a operating system package as you might expect. And then you can go and manage it from the console. And then another component that's going to be going into my demo is that I use SageMaker. So obviously not something that you're going to be running necessarily on the edge, but the whole idea of that is that you're getting a whole bunch of ways of solving problems, and you're using SageMaker to accelerate some of that heavy lifting. So what I mean by that is a really good example is when I first built the demo for this presentation, we hadn't released an algorithm in SageMaker that did object detection. So Jenny in the previous session showed us how she did an object classification demo. So that can look at a video feed and say the person is wearing a helmet, the person is not wearing a helmet. But I'm not quite sure where the helmet is. I just know that it's somewhere in the picture. So object detection is a little bit different, and this is about drawing a box around that particular object that you're looking for. This is now a built-in feature that you can use out of the box in SageMaker. And that would have saved me about 3 nights of rage coding trying to get this demo actually working. So thanks, SageMaker. You've made my life a little bit easier, but not in time for this demo. But a really good example of how the world keeps moving. And even the DeepLens, like the packages that are on the DeepLens now compared to 3 months ago, are way smoother and really, really slick to actually go and deploy models and deploy stuff. So when we talk about SageMaker, there are 3 key silos of capabilities that you'd really want to use. The first one is around building, and that's mainly around the managed Jupyter Notebooks environment, where you can go and get your algorithms of choice, some of which are out of the box, and you can go and use those. The training bit is really interesting because it's not necessarily just about being able to run training on 10 different super expensive but super fast NVIDIA GPUs at the same time. The value of this training stuff is when you give SageMaker a job to do training, it starts the instances up when you're running your training, and when the training is finished, it shuts them down and kills them off, so you don't have to pay for them. So if you've got a whole bunch of developers who are playing with this tech, the amount of money that you can waste by accidentally leaving GPUs running is really, really high. And I see in some of the deep learning meetups that I go to, people need to be really careful if they're running big, expensive instances that they remember to shut them down. And that's a good intention. But a mechanism to make sure that things get shut down when the training's finished is using the SageMaker training algorithm. Everything dies when it's finished. So it's a really efficient way of using that compute. And we're not really going to talk about deploying SageMaker endpoints because we're deploying using AWS Greengrass ML inference instead. And again, this is something that you can go and install on any device, not just a DeepLens. Cool. So we've gone from that build, the train, and the deploy part of solving this problem. But what about collecting data? We spoke a lot about the mechanics of doing this, but really the most important thing to consider here is how you are going to collect data to help build a model to solve your problem, right? A driverless car doesn't understand what a white road looks like with snow on it until it has been trained with that kind of information. And we're seeing an open ecosystem where a lot of machine learning algorithms are getting better every day, and you can just go and use them using tools like SageMaker. But so it comes down to thinking about what your competitive advantage is, and it really is around your data sets, not necessarily around the algorithms that are actually going to go and sit in it. So building the model using SageMaker, you import your data, and I'll go over this fairly quickly because there have been other sessions that have spoken about this. You import your data, train the model, and there's a really good workshop on GitHub that you can use. You can have a look at where we particularly did this for a DeepLens device and deployed that out. But it's just MXNet or TensorFlow. And then you deploy the model and the inference code using Greengrass. So this is what the console looks like. The DeepLens basically has a concept of a combination of a model and a Lambda function. So you really need to deploy both the Lambda function to understand to run through the ML model and the model through, and they're just that's it really. So you can also import a model, an MXNet or a TensorFlow model directly from S3, so you don't necessarily have to use SageMaker to build it. And you can just feed it the kind of library that it uses. So just to recap, you've got a scene. That image is going into the DeepLens, and then you can, I haven't shown you this, but you can basically just look like a webcam straight through and see the feed coming through the DeepLens. But what becomes interesting is that image goes through a Lambda function. The Lambda function pushes the image through a model, an MXNet or a TensorFlow model, and then you get data out of that. So when we think about IoT and getting really smart, this is a very interesting device for turning the analog world into the digital world and using a lot of intelligence that you previously would not be able to use at the edge. And then also you get the project stream, so you can see the output with boxes drawn around it like I demoed earlier. And this is what a function looks like. There's a couple of libraries that you need to import. This is just basically a hello world function that you'll be able to see in the Lambda console if you get started on a Greengrass project. IoT topic. And the way to think about how the Lambda function is running on this device is it's running in a hot loop. And there's a couple of parallel hot loops. This one is actually constantly looking for new images and pushing that out to an output thread. And that output thread is providing the video feed so we can see what's happening like as I demo it. And then there's the inference function. The inference function is getting a new capture from the DeepLens. It is running it through the model. Sorry, this is getting set up. So this is loading the model, setting up the topic, and then specifying that you're going to run it on the GPU. And then this is an infinite loop. So we normally think about Lambda functions as event-driven because we have an HTTP request, or we have a DynamoDB stream, or an S3 put, and that's normally what is going to trigger a Lambda function to execute. But this is actually, think of it as the trigger is a new frame. And the whole idea is we're trying to get through as many frames per second via the DeepLens to understand what we're seeing as we can. So this is that hot loop, pulling an image in, and then the one line at the bottom is running the inference through the model on the GPU of the DeepLens, because we've specified that. So you can run the inference on a CPU, hence the reference to a Raspberry Pi, but you may get a different sort of amount of frames per second. So just to recap, image is going in, it's being captured by that Lambda function we just described. The Lambda function is pushing the imagery through the model and getting data back, and then we're deciding to either publish that over MQTT or have a visual output. So the MQTT feed says, I can see a chair, I can see a person, I can see a table, right? That's just the model I was showing you earlier. And then the visual output says, I can see a chair, I can see a TV monitor, I can see a person with a wine problem. So yes, that is my home office, and that was about 2 a.m. when I finally got this thing to work, so that was great. So just to quickly go into some of the tech around how to use MXNet with this, there are a bunch of MXNet layers that you can use that are kind of whitelisted to work on the Intel GPU. And there's actually correlating ones for TensorFlow now as well. Gluon is like a higher level language that you can use to describe MXNet stuff. If you don't understand what this means, that's okay. Most of the out-of-the-box, well, all of the out-of-the-box things that work with DeepLens obviously only use these layers. And the reason that it only supports that set of layers is because it's transferring the MXNet or TensorFlow model into a hardware description language that runs better on the Intel GPU. So the inference is actually running on the GPU, not on the CPU. And this is one line of code that will call the Intel model optimizer and do that for you. Cool. Right, so let's cut over to the demo again, please. And this is an app that I used to tag and collect some training data. I wanted to build a single-shot detector model, a model that actually does object detection and will draw a box around stuff, to show, to detect my poor black and white photocopier version of the mining sign that you saw in a previous slide. And so I did this thing, and I went and took these photos, and to actually classify them, you've got to draw the box, because the model needs to actually understand where this stuff is in the picture. Don't know what I'm doing. Sorry. Next image. Proceed anyway. Yes. Okay. So I then started getting lazy because I realized that I could just take photos of heaps of these things in the same image and then draw lots of boxes. And I only did a couple of 100 images. I started doing outside lighting, and then my dog got really interested. And the reason my dog was interested because I thought I'd make it a bit more of an interactive demo. So I started driving this thing around and just capturing the video as it went. But we ended up with a pretty interesting model. So I used this thing called the MXNet, which is a really great way to get started using deep learning, and this is its implementation of a single-shot multi-box object detector. It walks you through the way of doing this on GitHub, and it's got training data, so you can build an example of it without necessarily having to collect training data. So I did this, but just repackaged my images for what I showed you earlier. And as I said earlier, this is now a native feature of SageMaker. So you can just go and use the built-in SageMaker image object detection algorithm, and you can save yourself quite a lot of time of translating what's in GitHub to what will actually operationally work. So we ended up with a model that, where are we? That should be able to recognize some of these mining signs. I'm just going to reload this page. You used to have to demo this by actually logging into the DeepLens, but there's a new feature that is actually enabling the DeepLens video over the network via a web page, and it is letting me down at the moment. So excuse me for a tick while I just try and restart it. I beg your pardon? No, it actually has TLS mutual certificate. That should be working on here, but it seems to be not responding. So let me just try one more. Otherwise, I'm going to have to go to the backup. There also might be a lot of RF noise in here, but this should be working. I've got a really beefy wireless access point sitting underneath here. So I'm just going to double check what's going on here. And we might have to fly blind, and just instead of showing you the video output, I will just show you the MQTT feed, because that seems to be working just fine. So the idea of this demo is that it should be showing you the video feed of this DeepLens quite nicely, but without having to, but actually streaming it. So let's see. Here we go. So that's the live stream. So if I move this truck, we should see that updating. And I'm just going to load the project stream. We'll see if that comes up. Demo gods are with me a little bit. So I'm going to change the demo a little bit because do we have visual? Okay. So I'm going to cut back to the last bit, but basically, Sorry, guys. I've got 2 different web apps running. And I'm just going to double check what IP this has. 53, and it's running on port 8000. So that should be working. I'm having massive Chrome issues today. Let me just see if I can fire up Firefox. All right, so what we've got here is basically, I wanted to show you the video feed, but it's kind of sucking, and I think I've crashed Chrome somehow. But basically, the model is detecting these signs, and then it's using those signs as a crop, and then reading what's on the sign, and mapping that to where it is. So we can see we've got my dodgy little programmed icon there. So if we drive this around, we should be able to see that this will change. It'll get a different crop. And we can look at the feed of what's coming up. And that's not, we're not loving this today. Sorry, guys. Cool, we've only got a couple of minutes left. So that's been a bit of a demo fail for you today, guys. So I have to apologize about that. The general idea is that this guy has been, and I do love my job. I get to drive a remote control car around on stage. That's just dropped its battery, so I'm going to fix that. And I'm just going to leave that there. Can we cut back to the slides, please? Oh, did it work? Okay, cut back to the slides. How good is that? So, look, I mean, the whole idea of this is that it's translating a, something that you would only expect a person to be able to read and see into data that is really useful for all kinds of systems. So in an underground mining situation, this stuff is super useful to understand where your trucks have been and where they've been taking dirt from underground. As simple as that sounds, a lot of mining companies don't even understand where they're going, and sometimes people take it from the wrong place and destroy the entire life of the mine by altering the way dirt falls down. So just the ability to be able to collect this data, where I was, and then funnel that back up online over time, makes reporting systems super, fills gaps where where you didn't have data before into places where you can really understand what has been happening. And I know they say software is eating the world. I think deep learning, to a certain extent, is eating software, because lots and lots of companies are finding small problems that they couldn't necessarily fix just in pure code, and they are taking those problems and they're solving just little problems at a time using machine learning embedded in their application. And that ends up giving a better application for your end users, and it gives you a competitive advantage. So, slightly dodgy demo over. Have a think about how you can apply this kind of intelligence at the edge and use this technology as a scaling function where you don't have to rely on people's attention, and you can start relying on the attention of devices at scale of tens or hundreds of thousands. Thank you very much for your time and your patience with that demo. I hope you have a great rest of your afternoon, and thank you very much for coming.